All right, my friends, let's have some fun here with sine of x. The way that we learned to generate this in section 8.7, which is the fallback, but it's also some work, right? So here f of x is sine of x. And so a Maclaurin series would basically have infinitely many terms, but you generate it the way you would have generated a Maclaurin polynomial back in section 8.7. So, f prime derivative of sine is cosine. F double prime derivative of cosine is the opposite of sine. F triple prime would be the opposite of cosine. And then when you get back to the fourth derivative, you kind of like cycle back around, kind of start over, if that makes sense. So, because the derivative of negative cosine is positive sine, etc. Okay, now since it's a Maclaurin series, it's centered at 0. So let's get all these evaluated at 0. And then, somebody wanted to know, well, what's the fifth derivative at 0? I would probably say it's 1, just based on the cyclic pattern here. Etc. Okay, so now that we've generated all of these values, now it's just a matter of generating the terms. So sine of x would be f of 0, which was 0, plus f prime of 0, which was 1, times x divided by 1 factorial, plus f double prime of 0, which was 0, times x squared divided by 2 factorial, plus f triple prime of 0, which was negative 1, x cubed divided by 3 factorial, plus 0, x to the 4th over 4 factorial, plus 1, x to the 5th over 5 factorial, etc. All right, now simplifying it, basically I took it out as far as I needed to make it so that when I simplify it, I still have at least 3 terms, because as soon as you have 3 terms, you'll be able to see a pattern that sine of x has of its own. So let's simplify this stuff. This is just x. This is negative x cubed over 3 factorial. This is x to the 5th over 5 factorial. And you just need 3 terms to establish a pattern. So you could say minus dot, 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 I suppose, or plus dot, 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 I guess, if you want. But anyway, let's say I asked you for the next term in this simplified version of the answer. What would you say it is? And if you can tell me what it is, then you've noticed that the simplified version of sine here has a nice little pattern. I'm going to replace x with x to the 1st over 1 factorial. So if you don't see the pattern, if you didn't see it before, hopefully you see it now. So sine has all odd powers and all odd factorials, and the exponents or powers and factorials match. So the next term, I hope it makes sense, would have been x to the 7th over 7 factorial. If somebody wanted the next one, I would say it's positive x to the 9th over 9 factorial, etc. Because I hope it makes sense also that the signs will alternate. Fun fact, this is one of the 3 series that I would say you should memorize. I used to have students memorize more than 3, and it was hard on people, to be honest with you. And I've learned unnecessary, but this one you need to have memorized. You do not need to write x as x to the 1st over 1 factorial, unless that helps you to see the pattern. So fun fact also, I don't know if you remember back in the past in pre-cal, you were probably asked at least once whether sine is an even or an odd function. And sine was an odd function simply because its graph showed rotational symmetry about the origin type stuff. Anyway, and at the time, you were probably told by your pre-cal teacher that it has nothing to do with sine having odd exponents like it can with other functions, but you were definitely lied to, because it turns out sine of x is represented as an infinite polynomial with all odd exponents. So if that helps you remember the odd numbers, sine's an odd function and it's got all odd exponents and all odd factorials, then great. Anyway, the point is you got to memorize that. And now this lesson is all about how, if you do have something like this memorized, how much mileage can you get out of it? So we're not going to do, actually, maybe I lied. Let's call this example 1. We are going to do structured examples. Okay. So example 1, what I'd like for you to do is write each given function as a Maclaurin series. So let's say for part A, I give you sine of the quantity x cubed, okay? There's more than one way to do this. So I think what I'll do is butt out, let you brainstorm on how to do it. See if you can think of more than one way to do it, okay? Because for this one, there's a long way and a short way. So see if you can come up with at least one way, preferably 2 ways that you could go about it. And then, see what you can do and check in with me in the next video.